Episode 111, Special Asteroid Delivery. And welcome back to another edition of the Syzygy podcast. My name is Chris Stewart, and I'm sitting at the table in the office of one Dr. Emily Dr. Emily Brunsden. Emily, how you doing?
I'm well, thank you.
I just tripped over your name. That's uncharacteristic.
So we've only been doing this for how many years?
I don't know. Who even are you? I don't know anymore. How you doing? How's things?
Yeah, it's good. It's a sunny day.
It is a sunny day. We've got the window open. You might be able to hear the breeze blowing in the background. And it's the beginning of semester
Yep.
Here at the University of York, which means that there's lots of bright-eyed, bushy-tailed students running around. How's it going? Has it kicked off well?
It's good. Yeah, it's nice. This is the nice time of year where everyone's, got the brand new pencil cases and the smell of
you
the
mentioned
wooden
that
pencils.
last time. It's like the pencil. Do students actually still have pencil cases?
Well, lecturers do.
Right. Well, this lecture does anyway. To Emily, that's the most important part. Yeah. Well, look, hope the rest of the year goes well. But we're not here to talk about undergraduate students at the University of York. We're here to talk about astronomy. And something has happened this week. There was a big news story where something plonked down in the middle of the desert.
Yeah.
Emily, what are we talking about this week?
Well, I don't know what you thought when you saw this picture, but it looked like two large woks stuck together, just left in the middle of the desert by somebody.
Or one of those crazy, like, hippie kettle drum type things where you see people sort of busking, where they're playing the big UFO-shaped thing and tapping it with their fingers. And so it kind of looked almost like one of those. But it's a big sort of UFO-shaped thing that plonked down in the middle of the desert this week. And loads of astronomers got really excited about it.
Oh, yes.
So we need to talk about that.
Yeah.
What is it? What's the mission? What's happened, Emily? What's going on?
Well, OSIRIS-REx.
OSIRIS-REx.
The parcel has landed.
The parcel.
Yes.
Okay.
The package. Your package has arrived. You know when you get that text message from...
you have a package. You have a package. Please leave a review.
Yeah.
OSIRIS-REx has landed. What is it and why has it landed? Where has this come from?
So this is a NASA mission that started quite a few years ago now. I think it was actually launched in 2016.
Right. So it is going back away.
Yeah. But this mission was to go to an asteroid, grab some bits off that asteroid and bring them back to Earth.
It's the sample return mission. Right. And am I right? This is the first time we've done this?
Oh, no.
No?
No.
I'm wrong then.
You are wrong because if you
wrong.
remember all the way back in episode 32,
we
talked about Ryugu.
Right. Yes, of course. It's slowly but surely putting this together in my brain.
Yep.
I knew we talked about something along these lines, but I didn't think we talked about this one.
No.
Okay. So just bring us up to speed. A sample return mission. I mean, it's kind of what it says on the tin, but what is a sample return mission?
I mean, it is pretty straightforward in a sense. You get spacecraft, send it to space, send it to, in this case, an asteroid,
right?
Get a bit of that asteroid, stick it in a little box, bring it back and drop it back onto Earth so that we can analyze it.
Which sounds really simple when you say it that way. Oh, all we have to do is launch a spaceship to a lump of rock flying through space, get a bit of it, bring it back and land it again so that we can analyze it. That's non-trivial.
Oh, absolutely
right?
non-trivial.
So, okay. We did talk about a sample return mission, Ryugu, I think you said. And what were the details of that one? Was that from the comet? No, I'm making this up.
It was another asteroid.
It was an asteroid.
We'll come back to that one because there's a couple of ones we can start to sort of compare this one to, I think, and sort of see where it sits in the grand scheme of sample return missions.
Sure.
But if maybe we drill down into this one and sort of look at what has happened basically this week or what's going on right now.
Okay, so what has happened this week? I mean, a UFO-shaped lump of spaceship landed in a desert. Where did it land? Where are we looking?
Utah.
Here? Right.
Yeah. It kind of it's about the same size and shape as a small barbecue without legs, to give you a sense of scale.
Yeah. So this isn't huge.
No.
But it's still like a sizable chunk of stuff to get down through the atmosphere at speed. So that's not easy.
Yeah. So that's come down, and it's brought with it we expect it to be about 250 grams worth of this asteroid.
250 grams. So what? Quarter of a kilo. That's not a lot, but it's enough.
It's a large mug of coffee.
Yeah.
Right?
Yeah. Okay. So a coffee mug full of asteroid in the middle of a large barbecue has landed in Utah.
Yeah.
Excellent. And that went well? Everyone was happy with it?
Yeah, it's gone perfectly well.
The photo looks really quite serene. Like, look at your chapter art on your podcast player now or go and Google it. The picture of this thing just plonked, nestled down in the Utah desert as if like this is a perfectly ordinary day for landing a chunk of asteroid in a desert. Yeah. Like, why not?
You sort of almost expect to have a big crater or something where it's just boom, boom.
Yeah. Like it's boom and a big smoking crater and you're blowing the smoke away. And look, there it is on fire down the bottom there. Quick, go and put it out. No, it's just this thing just sitting there, which is cool.
Yeah, that's very nice.
If sort of unexpected.
Yeah. Yeah. So this mission went to an asteroid called Bennu. Or also known as 101955 Bennu.
Bennu's better.
Yeah, Bennu. And really, I guess the important takeaway is that it's the first large sample of asteroid. I mean, large, small, whatever. It's orders of magnitude pretty much bigger than what we had before. And it's the first that's come from this kind of asteroid, which is also really important.
Okay, so it's not the first sample return that we've done. No. But it's the biggest?
It's the biggest.
Right.
And it's the first for this one. Yeah. So what other returns we have had, so let's go there now. So JAXA has actually returned 2 samples.
That's the Japanese space equivalent of NASA.
Yep. So they first had a 1 milligram return from a asteroid called Itokawa. And that was in 2005.
1 milligram is not a lot.
No, that's really quite small.
Yeah. I mean, look, getting anything back at all, I think, is impressive. But if it means that you've got to limit yourself to 1 milligram, I guess, okay, that'll do. That was the first one?
Yeah. And as we discussed at length in episode 32, the next mission, Hayabusa 2, well, the next successful mission, Hayabusa 2, returned 5.4 grams from an asteroid called Ryugu.
So we've gone from 1 gram to 5 and a bit grams.
Yep.
Yeah.
And that was 2019.
On the one hand, that's a 500 and something % increase. On the other hand, it's still a very small amount.
Yes. But now we've got 250 grams.
Which is huge.
Yes.
Absolutely huge. Yes. So that's very exciting.
And this is from a carbon-rich asteroid. Okay. So Ryugu was from I think it was iron-rich asteroid. So there's asteroids come in lots of different shapes and sizes and compositions.
Right.
And there's all sorts of classifications of them. But they're largely based on their composition. And that sort of gives you a little bit of a hint of their history and their formation. So these carbon-rich asteroids are the ones that are expected to be kind of the oldest in the solar system. So all asteroids are really old, really. They've been around. Most of them are primordial, so they were kind of formed at the same time as the solar system. So
right, okay.
They go all the way back, which makes them wonderful records of what the forming solar system was like, because it's just kind of they've not done anything in the last 5 billion years or so. They've just sat there being asteroids.
So they're kind of like a time capsule of That's not how you say it. They're kind of like a time capsule of that early part of the solar system's creation.
Yeah.
They're just sort of winging their way around the solar system, carrying whatever they had at the time without going through lots of change. And so if we can go and have a look at that, that'll give us presumably information about what it was like back then.
Because you think about the Earth has gone through so many geological, chemical processes. You've got mountains come up and then they go down, and then there's water weathering and lots of, almost everything.
Entire continents bashing into each other and creating mountains and stuff. Like
So the Earth is not a good record of what the solar system was like 5 billion years ago, because it's changed a lot. So, but these asteroids are. And they're largely found in the asteroid belt, kind of on the edges typically. So they're orbiting the sun somewhere between Mars and Jupiter.
And just as a quick aside, just reminds me, I know we have talked about this, but I think it was like a long time ago. The asteroid belt, like what's that again? Like why is there an asteroid belt? Was it a planet that blew up or what?
It depends on which model of solar system creation you subscribe to.
Okay,
but generally it can be sort of thought about, at least unambiguously, as an area of the solar system where a planet couldn't form. So
Right.
it was the gravitational effects that were going on between the sun tugging on Jupiter, Saturn, whatever planetary migration would have happened in the early solar system. It just, the stuff that's there didn't allow a planet to form out of it.
Okay. So whereas in other parts of the solar system, clearly planets did form out of all of the stuff, in the region of the asteroid belt, that just couldn't get itself together.
Yeah.
It's not that there was a planet that got torn apart. It's that there just wasn't one. At any point,
Although some
we
models
think.
do suggest that maybe
Right.
there could have been something that was
Right.
torn
Okay.
apart.
So jury's still out on that.
Yeah.
One. Okay. Regardless, there is this area where there's a lot of asteroids.
Yeah.
It's not quite like in Star Wars, though, in The Empire Strikes Back, where they're all just like there's asteroids everywhere. Like it's a bit more spread out than
Well,
that.
I guess you could think about it as being a bit like that if you shrink the size of the asteroids to very, very small.
Right. Okay.
I mean, there's lots of really tiny bits of space dust kind of everywhere.
Yeah.
But no, the big lumps that we're seeing are much further spaced apart than you would get on your classic video game.
Yeah. Although then again, we never do find out in Star Wars exactly what the scale is. Like it could be that, Luke Skywalker is actually really small and the Millennium Falcon is like, this tiny little thing. We don't know. All I'm saying.
Maybe.
Anyway, I think we're getting sidetracked.
Yeah, a
The
little
point
bit.
is there are asteroids and there are
Yep.
different kinds of asteroids. You
Yep.
said a minute ago that the ones that had been visited previously and samples brought back were from, I think you said iron rich?
I think the Ryugu was an irony? The irony is.
Irony.
Irony sort of one. So
Yep.
a slightly different composition. So this one is, carbon rich. So which, of course, when you get carbon, that means you're expecting to get organics.
Right.
Because hydrocarbons and so on obviously need the element carbon.
Mhm.
And what I think planetary scientists are really excited to perhaps find are nucleobases.
What's a nucleobase?
And nucleobases are the building blocks of DNA and RNA.
Oh, okay.
So they're kind of complex organic compounds that go on to form. Yeah.
And to be clear, when we're talking about organics and these kinds of bases, it's not organic in the sense of your produce is organic. We're not talking about living things. We're not talking about life, plants, and so on. We're talking about organic chemistry.
Mm-hmm.
And organic chemistry basically means stuff with carbon and oxygen, presumably.
Yep. Hydrogen.
Yeah.
Yeah. Those
sorts of things, which are the building blocks for all of the stuff that is in life here on Earth.
Mm-hmm.
And the more complex molecules that you can build up, including things like these bases that go on to, which are just, they're just chemicals, they're molecules, which can glom together to make really clever things like DNA. But we're not saying that these asteroids have DNA in them. That's not what we're saying.
No,
although that would be cool if they did turn it
exactly.
up, but we're not holding our breath.
Exactly.
Yeah.
Although nucleobases have been detected in samples on Earth that are from asteroids, it's just not 100% clear that those were pure samples.
It might have been contaminated
That could have been
our stuff.
Yeah, the problem is on Earth that life is absolutely everywhere. Yeah. So we've kind of polluted everything in that sense, so that it's very difficult to say that something's pristine and clear.
Yeah.
And that's why going and getting these samples is so important, because you're
And
absolutely guaranteed that they're
bringing them back really carefully.
Oh, yes.
You can't just sort of fling them down in the middle of the desert and go, there you go.
No.
Which then makes it all the more impressive that you can just land this thing in the middle of the desert with its payload intact and still keep it pristine inside. Well done, everyone involved. That's pretty impressive.
And you see the pictures of now people working with them. Then they didn't just kind of go into the desert. I'll find it. We'll open it up, see what it looks like inside. Right? They take it. They clean it. They put it in a clean room. Everyone's the pictures that they're showing coming out now of people looking at the samples, or they're all in the big bunny suits.
Yes. Yeah. There'd be some pretty amazing outfits and big white rooms.
Yes.
Yeah, with triple airlocks and stuff.
Yes, very sterile nitrogen chambers that they're opening these things and things like that.
So that's all very exciting.
Yeah.
So just rewinding a little bit, when was the sample actually taken?
So it was taken, I should have looked up the exact date, but so the spacecraft was launched in 2016. It arrived in Bennu at 2018, and it left Bennu, well, at least the sample left Bennu in 2020.
Right. So it was there for quite a long time.
Yeah.
Just hanging out.
Well, there were a couple of flybys. It was doing a lot of other measurements of the asteroid as well, because the mission goal is not just the sample. That's part of the mission, a big part. But we need to know a lot about the asteroid, because when we come to one of the scientific goals of this whole mission, it's to kind of create the canonical asteroid of this type. So we can say, oh, we know its mass, we know its volume, we know lots about the surface brightness and all these other measurements that we want to make of it, so that when we combine that information with the chemical composition from studying the sample, we can characterize it really, really well. And that becomes kind of the exemplar of that type of asteroid.
So you're not going to go all the way to this asteroid, reach down, grab a mugful, stick it in your backpack and head home again. You're sticking around for a while.
Indeed,
you're going to take lots of pictures. You're going to scan it in all sorts of ways. I mean, what were they looking at?
Well, they were doing a lot of mapping of the surface, looking at the shapes and structures. And this is all done, of course, before the sample was taken, because the way the sample was taken was in itself a little bit destructive to the surface, right? We'll get to that, I'm sure.
Okay.
But yeah, so you want to know, it's not quite a sphere, this lump. Bennu's about 250 kilometers in radius.
Okay, that's pretty big.
So it's sizable.
Yeah.
And I did look it up, the mass of it. So the mass of it's about 7 times 10 to the 10 kilograms.
7 times 10 to the 10. So that's a lot. Hang on, I was about to try to figure out what that is. I said, no, hang on, that's a lot. That's like billions. 70 billion? 70?
Yeah, 70 billion. Yeah, 73
kilograms?
Billion.
So that's 73 million tons.
Yeah.
It's a lot.
It's a really awkward size too, because I was sort of trying to think, okay, how do we put this into something that you can actually imagine what this looks like?
Okay.
And so I thought, well, okay, what's the kind of the large or heavy objects that we would be familiar with? You can go to maybe some of the heaviest objects that are mobile, that are things like 747 400s.
Mm-hmm.
So you need, this is going to totally unhelpful.
This is not going to help, is it?
You need 163,000 of them to make up this asteroid.
Yeah, see, I can't imagine that.
That doesn't really work, does it?
It's not helping.
Then I thought, oh, well, the moon's quite big. Let's compare it to that.
Yeah, no,
it's a millionth,
much bigger.
It's millionth the size of the moon.
So somewhere between all of the planes on Earth and the moon.
Yeah.
In size.
Good. And I even got to the point where I asked AI to give me a good kind of comparison example.
How'd that work out? AI just shrugged and said, no, I've got nothing.
I asked it, what is a similar thing to this? And it told me a small asteroid.
Thanks, Tar. Yeah. It is its own defining object.
Yeah.
There you go. Listeners, if you ever need to know roughly what is 700 or 70 million kilograms, 70 million tons, it's a small asteroid, and that's your defining lump. So there you go. Good. I'm glad we figured that out.
Sometimes you just can't make things easily understandable.
No, that'll do. Okay, cool.
Anyway, so that's what Bennu is like.
You had on your screen. It's now gone to the screensaver. But we have there's a picture or a little video playing, which is take me through this. It looks like we're landing. So is this did we land on Bennu, or is this taking the sample, or what's going on?
This is quite interesting. So the way that the sample was collected was through a quote unquote puff of gas.
Right.
So OSIRIS-REx didn't land on the asteroid. It sort of got quite close and then kind of basically farted at it. A really sort of...
I don't think NASA would call it that, would they? That's not official terminology.
I don't know.
Maybe it is.
It was quite a pressurized... They called it a puff. I mean, a puff is way too gentle.
We'll call fart. Okay.
Yeah.
Yep.
It just farted in its general direction.
Yep.
And then a whole lot of the dusty, because it's the surface is kind of, it's not a solid surface. It's a bit like the moon, you got all the moon dust.
Right.
That's kind of...
Is that because it's so small that it is like it's clumped together with gravity, but there's not a lot of gravity because it's not very big. And
yeah, that, and it's just collected all this stuff from just hanging out in the asteroid belt. It just flies into bits of dust, and bits of dust just stick to it.
Yeah.
So
okay,
it's just there. So it did this puff, collected the dust and little tiny bits of rocks. It worked a little bit too well.
Got a bit much?
Yeah.
Too much?
Well, there's a bit too much. It actually clogged up the kind of collector a little bit.
Excellent.
So
did they not anticipate it was going to be quite so dusty? I
guess not.
I mean, until you've been there and done it, until you've gone up and actually farted on an asteroid, you don't know what the ramifications of that is.
You don't.
Yeah.
So they did actually lose some of the smaller pebbles around about a few centimeters, but they still think there might be some that are around about a centimeter in size in the mug of collective stuff.
The mug of asteroid gunk that they managed to fart off the surface. Good.
Yeah. So that's how they collected it, and then they parceled it all out. It's actually in several different layers. I didn't get to discovering exactly how many, but there's layers within layers. So you sort of open the first layer, and then there's kind of a little bit of stuff. And actually, on the very outer sort of protected a layer. What's the word I'm looking
Container?
for? Yeah, there's kind of the outermost container. There's about 100 milligrams of material there, which has been allocated for a quick look team.
Okay.
So they just take this straight away, and they said within 72 hours. So kind of by now, basically, because we're recording this on the 29th. Asteroid landed on the 24th.
The spacecraft landed on the 24th.
Sorry, the asteroid. Well, bits of the asteroid landed. So this team have basically been looking at this material as kind of like
I love it. That's a little
bit
thing
like,
like some families on like Christmas Day will have. Well, we'll do all the presents under the tree later on, but you can open one now.
Yeah,
this
exactly.
This is a little bit like that. It's like, come on, scientists, here
it's
you go.
It's a lot like that.
Here you go. Go and analyze this one.
Yeah,
and we'll save the really important stuff for later.
Exactly. I mean, you say Christmas. I was going to bring this in at the end, but I'll bring it in now.
Okay.
There's a wonderful quote from one of the Quick Look team. Actually, it says, "I felt like a kid on Christmas Eve who was just too excited to go to sleep." And that was from Michelle Thompson.
Except normally your Christmas presents aren't delivered by Santa by bashing them down into the desert at high speed. But, that just adds a level of excitement.
Well, maybe he should consider it.
Maybe he should. Yeah, you can write that to him in your next Christmas letter.
I will. Yeah, so that's quite exciting, that first 100 grams. And then the rest of it, so it was quite interesting, actually, to read how it's all going to be divvied up and sort of looked at. So about 70% of it is being saved for scientists outside of NASA's organization to look at. So that's, I guess, part of it will be stored, and part of it will be, I guess, you submit a proposal, you want to do some studies on some bits of it.
Well, I'd imagine there'd be loads of different people wanting to look at this stuff in loads of different ways.
Of course.
Like this is not just bung it under the microscope and take a look. There are just enormous amounts of things you'd want to know from all sorts of different angles, I would think.
Yeah, no, that's exactly the case. About 4% of it is going to the Canadian Space Agency, and that's because they built one of the laser instruments to go on the OSIRIS-REx.
Okay.
Yeah.
We'll give you a laser, but we want some of the rock.
Yeah, it's quite interesting. I mean, I'm used to thinking about buying into telescope time, right? So often different collaborations, when you pay in a certain amount of money to fund a telescope, then you get a certain percentage of that telescope's observing time. That's fairly standard.
Yep.
This is, you build an instrument for a spacecraft and you get a percentage of the dust it brings back.
The sample returned. I think that's totally fair. You want my laser, you give me some rock. I think that's cool.
Nice.
Yeah, okay.
And here's the best one.
Yeah.
So about 0.5% of the sample is being exchanged with JAXA,
the Japanese
Space Agency, because they're swapping it for some Ryugu sample.
Oh, okay.
So
give us some of yours. We'll give you some of ours.
Yeah.
Do a bit of a comparison.
I've got this wonderful vision in my head now of all the space agencies of the world coming together in some kind of event and saying, well, I've got a bit of Ryugu. I'll swap you for a little bit of
I'm imagining it like sort of Cold War spy style, where they're meeting on a bridge at midnight, and they're wearing trench coats and going, all right, you can have a bit of this, you can have a bit of that. And we both let go at the same time. There we go. And then you go back again.
Yeah. No, I was thinking more like the stickers.
Yeah, well, that could work too.
Yeah, I've got a shiny one. That's worth more.
Excellent. All right. So that's going. So the early that sort of that outer layer that's being examined now by the very excitable scientists who get to open their Christmas present early, and then the rest of it is being divvied up very, very carefully in incredibly careful clean rooms and so on over a period of time.
Yeah.
So what are we hoping to get out of this?
Well, it's a very good question. So, I mean, we sort of alluded to some of the things already, but we can go through formally what the mission kind of goals are and what we're trying to understand. And many of these are quite long-term things, right? These are not necessarily what the Quick Look team are doing.
Well, we're going to give them longer than 3 days, are we?
Yeah.
Right. Fair.
Yeah. Fair. But that's fine. So the overall mission is looking at the formation and evolution of the early solar system. And actually, this is probably a good point to wrap around and actually ask the question of what does OSIRIS-REx actually mean?
Yeah, it's an interesting name. So why OSIRIS-REx?
Well,
glad you asked, she said.
I am glad you asked because I wrote it down. It's an acronym, of course. So it's origins, spectral interpretation, resource identification, security, regolith, explorer.
Wow. Okay. There's a lot in that. They worked hard for that one.
Yeah. I'm not even sure I understand what all of those words mean. So I had to look them up.
So take us through it bit by bit.
I mean, so origins. So this is, again, so
origins of the solar system?
Exactly.
That's where we're coming from here?
Yeah, that's where it's going with. Spectral interpretation. I guess
we're looking at it.
We're going to look at the chemical composition.
Yep.
Yeah, you could do that with spectral sort of analysis techniques. Yeah, mass spectrometers you might have heard of from, 90s crime scene programs. Resource identification. Yeah.
What's in it that might be useful?
Yeah, I guess, perhaps.
Yeah. Maybe a bit of asteroid mining in the future.
Possibly, I guess. Security. That was interesting.
So what? Trying to figure out any information that might help us to stop one of these things slamming into a major city at some point?
Yeah, that's obvious now. When I read it, I was very confused.
Yeah.
But
I'm guessing that's what it means.
That is what it is.
I can't really think of
but
any other interpretation of security.
One.
I mean, unless they find, aggressive aliens hiding inside, I think the only other security option we've got is it coming towards us?
Yeah, well, so security in that sense, but it's also actually, it is a bit more scientific than that. So we're looking at why or how asteroids might come close to the Earth and therefore pose potentially a threat. There's a particular effect called the Yarkovsky effect, which is to do with how asteroids move under thermal forces. And so how do they respond to that, and how do their trajectories through space change because of that? So it's all tied up in that, because we want to understand how their trajectories work so that we can prepare or indeed perhaps protect ourselves from these kinds of objects.
Yeah, I guess that makes sense. That if you roll that film forward, we've discovered that there's a large chunk of rock coming towards the Earth that threatens our existence. What are we going to do about it? And we're going to have to go and meet that rock and do something. And so we'd like to understand, if we try to blow it up or shine a really big laser at it or bash something into it or whatever it might be, how is it going to respond? Yeah. Because you want to try to know that in advance, not just make it up on the day.
Yeah. We are actually looking up.
Yeah. And I'm glad. I'm glad someone is.
Indeed. So that's part of that side. And regolith is referring to this kind of loose layer which covers the surface of planets or planetary objects.
Is like granular rock, isn't it? It's like dusty, rocky, pebbly stuff. Yeah.
So that's what regolith is.
Okay.
And explorer, EX, you kind of
exploring.
Needed to get somewhere. You need to get the X in there. And Osiris is a ancient Greek mythological god, or the ancient Egyptian. My goodness.
I was about to say, I thought it was Egyptian. Yeah.
Ancient Egyptian, major god, the god.
One of the big ones.
Yep. At some points. So quite important.
Okay. So hard to know at this point whether or not they reverse engineered the acronym or whether they came up with a few letters and went, hang on, if we just throw a few more in there, we've basically got an Egyptian god.
I think it was the latter, reading some of the commentary on that. Yeah.
Good.
I think at least one of the main PIs was quite into Egyptian mythology. So
Excellent. I mean, if you're 3/4 of the way there, you just fill in the rest and reverse engineer.
Yeah, it's important for funding applications.
Yeah, got to have a good name.
Yeah. So that's kind of, I think, covers most of them. So we're looking at formation and evolution of the early solar system. We're going to obviously do the sample study. We're going to map the global properties of this asteroid to try and find out what this asteroid is, and particularly to turn it into this canonical example of this type of asteroid, and look at also, threats to our own
threats
planet.
To our future existence. Yeah. Which is that's a lot of weight on a small sample of stuff brought back from an asteroid that's landed in the middle of Utah somewhere. But I guess, like, I'm imagining a mug full of stuff, 250 grams, and while that's not a huge lump of rock, it's not small either.
No.
Like, you could divide that up many ways and give lots and lots and lots of people little bits of a sample. It's not like you need a large chunk of it in order to do a lot of this testing. Right?
No.
You could do a lot of stuff with very small amounts.
Exactly. Yeah. And actually, this is not the whole mission as well. The mission continues. So the part that's come back to Earth, I guess, is part of what would be called the OSIRIS-REx mission.
Right.
And I did actually go and look, and perhaps I shouldn't have, at the Wikipedia talk page about this, because there's discussion about whether to change the Wikipedia article title, given that the OSIRIS-REx mission has now ended, and we're now in the phase of OSIRIS Apex. So the sample bit got sent back to Earth, right? But the rest of the spacecraft is carrying on. And going to do some more stuff. So it's going to go to another asteroid called Apophis, 99942.
So hang on, let's just rewind for a second. Can we just establish, where is Bennu? It's not, are we out at the asteroid belt? Where have we gone to do this?
So we're not quite that far away.
Yeah, because that's a really long way.
Yeah, that would be hard.
That's like between Mars and Jupiter. Like
Yes.
that's a stupidly long way away.
Yeah.
So, but we're not there.
No, so this is an asteroid from the asteroid belt
Right.
that, for unknown reasons, is not quite in the same asteroid belt orbit as it may have been in the past. And so it's now on this very eccentric orbit where it comes reasonably close to the Earth and then a little bit further away from it. So it comes. That's what makes it useful, right? We can get to it, basically.
Right. Yeah. Okay. That makes sense. So we've sent a spaceship up and gone to an asteroid which is it's not so close to the Earth that it's going to cause us a problem, but it's not so far away.
Yeah.
But then, just to be clear, a bit of that spaceship has now been flung back at us.
Mm-hmm.
And here's the bit that amazes me. Like, that wasn't a very large bit of spaceship that came back to us. I don't imagine it was covered in all sorts of amazing rocketry and so on. Like, I'm amazed that they managed to hit us.
Yeah.
You know, like, it could have just gone flinging off in any direction, but they managed to get it back and land it in Utah, which is pretty impressive. So well done. But not only that, it's still up there and it's now going to go on to another asteroid?
Yeah, so another asteroid called Apophis. And this is actually quite an interesting asteroid. So it's a different type of asteroid. So we haven't got the sample return anymore. That's all done.
Okay, that's
that
done and
module
dusted.
is detached and gone. But the spacecraft is going to continue to use the other instruments on board to study this next asteroid. It's a stony type asteroid. So it's a bit more, I guess, varied in its composition. It's
like, they all sound stony to me, but
yeah. this is a stony
it's a different
type.
one. Okay.
I'm told that's very different.
Okay.
Yeah, I'm sure it is.
Asteroid experts, if you're listening, do write in and let us know.
Yeah. But this is quite an interesting one because it did hit the news a couple of years ago when it did a reasonably close flyby to Earth. I think it came between the Earth and the Moon at one point.
Okay. Which, I mean, look, there's a lot of space between the Earth and the Moon. Like, you can fit all the other planets between the Earth and the Moon, which is a fact that I had forgotten until fairly recently. If you line all the planets up and fit them, they can fit between the Earth and the Moon.
Nice.
There's a lot of space there, including Jupiter and Saturn and all of that. It's a lot of space. On the other hand, on the scale of the solar system, it's not a lot. And so any sizable asteroid coming between us and the Moon is reason to sit up and take notice.
Exactly.
I think.
Yeah. So it did a flyby in 2021. So it's sort of, if you've heard the name before, that might be why.
Okay. What's the name again?
Apophis.
Apophis.
So it's another, I think, mythological one.
Sure.
I'm not skilled enough to remember that one.
I'll look it up. I'll put a link in the show notes.
But it's quite interesting because in 2029, which is actually when OSIRIS Apex is going to meet up with this asteroid, it's coming back again. So it's on a orbit of the sun where it's going to meet up again with the Earth. And this flyby is going to be much closer, actually. So it's only going to be maybe around 40,000 kilometers away from the Earth.
40,000. That's quite close.
It's quite close,
it? Yes.
Yeah. Well, it's kind of 20,000 k's from the UK to Australia.
Yeah,
something like that. a bit less.
That's a bit disturbingly close, to be honest.
Yeah, exactly.
Yeah.
So this is the altitude that some of our high satellites orbit at. So yeah, that's interesting.
Yeah.
So it's not. It's nothing to worry about.
Just to be clear, everyone, we're
fine.
fine. We're fine.
It's not going to.
I'm looking to Emily for reassurance here. We're fine, aren't we?
It's absolutely
we're good.
fine.
Yeah.
But it's
Astronomers
useful
have got
that
this in hand.
it's going to come close and it'll be quite exciting, I think.
Yeah.
Yeah. Not for the bad reasons.
Yeah, not exciting in a sort of existential crisis kind of way, but yeah.
For all the good reasons. Yeah.
And so coming that close means it's just a bit easier for us to go and say hello with our little spaceship. And so that one's not going to be grabbing a mugful and bringing it back.
No.
That's just taking a look.
That's just using all the other instruments to characterize it as much as we can. And the great thing is once we know, say we've got the canonical example of a carbon asteroid, we've got the canonical example of a stony one. Ryugu was a sort of irony one. So now when we go and look at the much further asteroids out in the asteroid belt, we can say, well, that one's one of those, so it must be like this.
Right. Yep.
It gives you a lot more information about how to work with the bigger populations when you've got these really good, well-studied samples.
We're building up a good catalogue of asteroids that we've properly studied up close. Yeah, okay.
Yeah, so it's all very exciting.
Yeah, so when's that going to be happening?
2029.
2029. So we've got a bit of a wait.
Yes.
So what's OSIRIS doing in the meantime? Just hanging around, getting ready.
Getting there.
Getting into the right orbit.
It takes a while to get places, it turns out. But to look forward to, perhaps, well, we'll see. There is scheduled a press conference to talk about the first look.
What was inside that early Christmas
first little
present?
peek? Yep. Yeah, exactly. That's scheduled for the 11th of October.
Okay, that's not very far away. A couple of weeks.
No, I mean, this is pending the current political situation in the US because if there is a government shutdown, there'll be a NASA shutdown.
The government's about to shut down unless they can get their act together. Come on, people. We want to know. We want to know what was in that present.
So that might be delayed by politics, but at this point, we can hope that goes ahead.
Yeah, because, of course, NASA, very much being a government institution, if the government closes down, then NASA really does.
Yes, it does. Yeah.
Presumably there are still people sort of, pressing all the appropriate buttons for the International Space Station and other bits and pieces.
I assume they have a base.
They'd have a skeleton
operational,
staff. Someone's paying attention somewhere.
Yeah, well, they got through COVID, right? So.
Yeah, I guess so. Yeah.
Yeah.
Excellent. So let's hope. Touch wood veneer tabletop. October 11th, we'll have that press conference, and we'll
and probably not too long afterwards, even if there is, if we have to wait an extra month for it. Hey, I mean, these scientists have been waiting for more than a decade since
Yes. Well, it just gives them a little bit more time to do some analysis.
Yeah. What's an extra month on that?
Exactly. And do we have any idea what we might expect to hear at said press conference?
It would be very cool if we got those nuclear bases, I think, because we're still trying to piece together the story of the origin of life, obviously. And although we're kind of moving away from the idea that life-bearing water sort of came to us from comets. That was quite a big idea.
That seemed to be the idea for quite a long time, but that's not
the evidence is not pointing that way anymore. So it's interesting to think about if there was these kind of building blocks of what would become life, if they're prolific throughout the solar system.
Yeah, I mean, if you can find them on any given asteroid that just happens to fling itself past, then there's clearly a lot of it out there.
Yeah, was basically life on Earth an inevitability given the amount of stuff in the solar system, and a part of it had to be at the right temperature and the right place at the right time.
Yeah, I mean, clearly the solar system isn't teeming with life. We don't have sort of monkeys on Saturn or anything like that. But if the building blocks are basically everywhere, then the inevitable part, presumably, is somewhere in the universe, some solar system somewhere, you're going to have a planet which has got the right conditions.
Yeah.
And there's a lot of big question marks on that. Like that's sort of a big black box of, but what conditions are they?
Yeah.
Is that just Earth, or is that Earth and like a trillion other planets as well? That's the bit that we haven't got yet. But at least having an answer to, but are the building blocks everywhere or not? That'd be cool.
So are we looking at maybe the excruciatingly unlikely to, well, I guess it could have happened maybe inevitably somewhere. And then that's a huge spectrum of probability, right? But having some pointer in that direction, I think in the next month or so would be quite exciting.
Yeah, I mean, it is a little bit like saying, yes, there are Lego bricks everywhere, so therefore a Lego model of the Taj Mahal is inevitable. So, well, okay. There's a lot of questions to answer.
But if the Lego bricks aren't everywhere, then a Lego model of the Taj Mahal becomes even more impressive.
Exactly. Exactly. So watch this space. So that's one. We might get some answers about that. Any other?
I think
any other
that's
big
my
questions?
big one personally. I think, it will take a bit longer, I think, to answer some of those deeper questions about things like that thermal movement of asteroids and how we track and how we protect up. That's all part of a much bigger, more complex picture.
Yeah.
I think.
Whereas
So
the nuclear sort of base idea. And by the way, is that the sort of the GTC and A style in DNA? Like that's what we're talking about.
What
the
is it?
Gattaca bit.
Alistair's cat. I don't know.
I can't remember what the names are, but those are the bits of the DNA, right?
Yeah.
Like presumably the tests for those are, well, we know what they look like. So are they there?
Yeah.
It's a yes or no.
I presume so. I'm not. Maybe I'm.
We might be
over the
oversimplifying this slightly. Yeah. People will write in and say it's a little bit more complicated than that,
Yes, I would expect that you could do that reasonably quickly with a small sample.
Okay, fingers crossed. Well, that would be very, very cool. So let's all hope, for a whole bunch of reasons, this being just one of them, that there isn't a government shutdown in the US. It'd be kind of nice to tune in on the 11th and find out. Well, finding our way out of this episode, number 111, number 111, a couple of things. First of all, I'm really excited to find out whether or not there are the building blocks of life on pretty much, give or take, asteroids throughout the entire solar system. That would be cool. And number two, I'm a little bit concerned about how close that next asteroid is going to be coming to the Earth. That sounds a bit too close for comfort, and I'd like them to not do that, please.
If it helps, we'll probably have much bigger problems by 2029.
It doesn't help, actually. But thank you for trying. Look, I think let's just move on from that. Emily, if there was someone out there who knew much more about regoliths or indeed, the basic building blocks of DNA, or indeed building Taj Mahals out of Lego bricks, if they wanted to write into us and go, oh, no, here's the details, how could someone get in touch with us here on the show?
I think you should send all of your complaint emails to Chris's personal email account, which is Chris.
No, don't do that. No. Instead, you should get in touch with us at the Syzygy HQ, which is where?
Syzygy.fm, of course.
That's correct. Yes. Go to Syzygy.fm. Go and find the contact page there. And there's a form that you can fill in. Fling it through to us, and we will address your comments on the show. And in fact, in the past, on occasion, we've even had really good questions that have come through that have turned into an entire episode. So do get in touch. We'd love to hear from you. It's always such fun when we hear from listeners out there in the world telling us about what they're thinking about and what they'd like to know. It's always great fun.
Indeed.
The other things you can do, of course, are head out to Instagram. We're on Instagram, Syzygy Pod.
Yep.
We're on Facebook. Do the Facebook thing. Just put it into the search bar. You'll find us.
Yep.
Or you can go over to patreon.com/SyzygyPod, where you can support us in doing what we do by flinging a couple of pounds our way every once in a while, every month, every year, whatever you want to do. Help us to keep the electrons flowing through the website and to do the things that we do here at Syzygy, spreading the joy of astronomy to the world. Otherwise, I guess we should probably wrap it up there. So, Emily, catch up with you in sort of give or take plus or minus a week in about a week's time.
Yes. See you later.
Talk to you soon. Bye, everybody.
Oh, I'm going to remember that one, though. Spreading the joy of astronomy through the world.
Well, we do.
I'll put it on my promotion application.
Put it on your... Yes, absolutely. Put it on your CV. Title.
Your package has arrived.
Your asteroid.
Can you rate Steve, who delivered your package?